Solar Panel Light Tracker Group. We are Group 12 of the ESET 462 final project. In this group, we have Nikita Chadhauri, Alvin Onwin, Aaron Outen, David Parker, and myself, Bianca Yolton. Our project involves building a prototype for a solar panel that is able to move its position along with the sun. This is to get maximum sunlight, and it makes solar panels more efficient, which helps to create more energy from the renewable resources such as solar energy. There are companies out there such as Array Technologies which have come up with solutions in which they have many motors which are able to turn the solar panel towards the sun. However, there are some limitations with some of the other existing products on the market, as they're cost ineffective or expensive, and they don't have a scope for individual panels, such as those for people in residential areas. Our plan is to create an inexpensive and a lightweight solution.
On the right is a simplification of our design. The key concept of this design is a PID controller that takes in the error between the desired photoresistance difference and the current photoresistance difference. The sum of each PID term will be sent back to the plant control, which will control the servo. We use a range of photoresistance difference for our input and the desired angle based on each of that specific input to find the transfer function using MATLAB. And the simulated model of a design are shown on the screen. You can see the discrete transfer function, and that will be controlled using the PID controller.
Our hardware system will primarily consist of a small DC servo motor that will attach to the solar panel. This will cause the solar panel to spin along one of its axes. There will also be two small photoresistors attached to either side of the solar panel. These pins will be connected to D2 and D3 on the ESP32 respectively, and they will provide feedback to the motor. The output signal for the motor will come from D5 on the ESP32, and both all of the components involved in this will receive both power and be grounded through the ESP32.
So for the software, we use the free RTOS code that was given to us in previous labs as a template for our code. We modified the code from the labs to be more readable, and then also we included servo controls into the code. For the input into the PID, we added both of the voltages given from the photoresistors, and then we used the output of the PID to control how many degrees the servo needed to move. And for the direction of the servo's movement, we determined that by subtracting the photoresistor voltages. So for our budget, a lot of stuff was free, either from previous classes we had the components or from lab. The two things we had to buy were photoresistors, which were a pack of them was worth $5, and then the ESP32, which was a microcontroller we used, and that was $27. And so this gave us a total of $32.
In this project, we learned how to use PID systems in a wide variety of systems and increase efficiency using PID in a wide range of applications. We also gained experience using MATLAB and the Arduino IDE, and we learned how to implement sensors such as photoresistors in a complex systems. This is the end of our presentation. Thanks a lot.